test yet? I think so, huh? No? A little bit, but not a lot, right? Like did I tell you about how you have to register and all for it? Okay, I told you that part. All right. Well, so just again, to refresh your memory, because I also forgot to, our test is going to be on September 16th and 17th. So remember that you can pick either of those 2 days, so September 16th or the 17th, and just any time that the lab is open, you can schedule a test there. Did I remind you of like how you can schedule it by going to like our course home and all that? Okay, and then sign up. Okay, so anybody have any questions so far about that? Everybody knows what to do so far if they've tried it. Were you able, Rebecca, didn't you say you had scheduled it, you need to cancel it and fix it?
It was super easy.
It was easy? Okay.
Yeah.
Okay, good. Good. Okay. So also just remember that I think I made all of your chapter 2 stuff. I think I made it due on September 15th, if I remember right. And Alex, I think that's what I made it do. So next Tuesday, that's going to be at 11:59 p.m. I think that's what I said. But all the stuff in Alex and on Moodle should be right. So just make sure you check, make sure you meet all the due dates. Okay? All right. So nobody has a question about the test. Everybody's okay with that so far? Okay, so on that day, like, which, I mean, you guys don't usually come on Thursday anyway, but on that day, like, we just won't have class. And then what I'll do is probably what I'll do is that Saturday, actually, is one of the days that's, like, our Saturday makeup. So I'll probably post, like, one set of the notes on the Saturday or, like, set it to release then. And then one set of notes, like, I usually do, like, on the Monday, just so that way you have an assignment. Okay, so you'll never have to come to class for that day. All right. Okay, so I think we finished like 2.1. Is that right? Yeah, I think we finished that whole section. Okay, so we have 2.2 and 2.3 left today, and then we'll just have one more section that we'll look at the following Tuesday, which is 2.4. Okay. All right. So let's look at 2.2 first, and then we'll look at this other section hopefully before the class ends. All right. So 2.2 is kind of just talking about some more information about sets. So 2.1 gave us just like a little bit of basic information. So this is just kind of adding on to kind of your basic definition so that when we get to 2.3 and 2.4, we can kind of just apply it all together. Okay, so remember like on Alex, I know it comes up kind of scrambled. So if you get to something that you're not sure about because we didn't go over it yet, remember on the top you can drop down that little arrow and like scroll side to side, and then that way you can do like different objectives if you need to. Okay. All right. So anyway, so this whole first page is talking about the universal set and the complement. Okay. So let's first kind of talk about that. So the best explanation I feel like I can give you of this is that if you think about the universal set, it's like the biggest set that you can choose from. And then usually you'll take like a little piece of that universal set, and then whatever is not in that piece that you just took is basically what the complement is. Okay, so an example, or to me, like something that maybe like a real life example might help you a little bit, is like if you think about the universal set as a set of all the students who are at Nichols, right? Okay, then maybe take a small set and say, okay, well, let's look at the set of only the people in 117 on Tuesdays, right? So that's you guys. Okay, well, then the complement of that would be all the rest of the Nichols students except for you guys, okay, because that's in my big set. So that's kind of like hopefully a little bit of like a more realistic way for you to kind of understand the universal set and the complement. Okay, so anytime they're asking you for the complement, they're always going to do something like this little A prime. So again, this is where you have to make sure you remember all the notations because all of them are going to come together in the last two sets. So like in the last two sections. So you have to make sure you really understand what the notations are. Okay, so one thing maybe I might suggest, which might also help you with your homework, if you make like a little index card or maybe just like a sheet of paper where you kind of just like jot down some of the most important notations, that might also help you so that when you see your homework on Alex, you could like remind yourself, and it might also help you learn it. Maybe. I don't know. I feel like that would maybe be helpful. All right, so I did all of number one with you, which was just basically kind of introducing you a little bit to Venn diagrams, and kind of showing you a little bit better what prime is, or a complement. That's the same thing. I keep saying that interchangeably, but the prime and the complement is the same thing. Okay, so does anybody have a question about one on that first page? Okay, well, so let's look at two, because two is the first one that I asked you to do on your own. So it says, let U equal this set, which is 10, 20, 30, counting by 10s all the way to 90, and then it gives me a set A. So it wants me to find A prime or A complement. Anybody want to try? Okay, Michael, what do you think it is?
Okay, I've got 20, 40, 60, 70, 80, 90.
Very good. 80 and 90. Okay, so how did you figure that out? What did you do?
Well, I just looked at A and then looked at U, and whatever was the same, I didn't put that.
Very good. That's exactly what I would do. Is anytime they're asking you for the prime or the complement, you just look at the two sets that they give you, and then you write, basically take everything out of the universal set that's in A, and whatever's left, that's going to be your answer. Okay, so that's how she got this. So she looked at it and she said, okay, well, 10 is an A, so don't write it. 20 is not an A, so I can write it, and just do that for the whole entire set. Very good. Good job. Okay, so the next one says, what is the complement of the empty set? So think about it like this. So remember, the complement means the opposite. Okay, so think about if the empty set is the set with nothing in it. So what do you think would be the opposite of having nothing? The what?
The whole set.
The whole set, right? So in our case, the whole set is called the universal set. Very good. So the answer for 2B would be universal set. Okay, because what's the opposite of having nothing? Would be having everything, or in our case, we call everything the universal set. Good job. Okay, so anybody have questions about kind of the basic definition so far at the top? All right, so let's go and look at subsets. Okay, so subsets and proper subsets, they're kind of going to go together. So we're kind of going to look at this part and the whole back kind of together right now. Okay, so here's again some more notations that I'm saying. You just kind of have to know their definition. Okay, so the first one is subset and the second one is proper subset. Okay, so this is the symbol for subset. This is the symbol for proper subset. Okay, so let's kind of talk about what those mean. Okay, so subset is basically you have a full set and you take pieces out of that set to make a new set. Okay, now those pieces could be one item, 5 items, or even the entire set, right? But a proper subset is just like this, where you're still taking pieces of a big set, except it can't be equal to itself. So it can take a piece out, 2 pieces out, 15 pieces out, but it just can't take out the whole set. Okay, so the way I kind of think of it is it's kind of think about when we talked about set builder notation. Think about that. Okay, so when we did set builder notation, we used inequalities. Remember we said less than, greater than, less than or equal to, greater than or equal to. Remember that? Okay, well, so it's kind of like this. They're kind of similar. So greater than and less than, those things, the greater than and the greater than or equal to, mean pretty much the same thing, except the only difference is that it can't use that last number right there, right? If I said greater than 5, okay, well then it would be everything greater than 5 except for not starting at 5, right? But when I say greater than or equal to, it's saying everything greater than 5 and 5. Okay, same thing here. They mean the exact same definition, it's just that it can't be itself for this one. That's the only thing. Okay, and when you're thinking about a subset or a proper subset, what you want to remember is that whatever piece you take out of the total, all that piece has to be in the original set as well. Okay, so I'm going to show you that when we kind of go through the true false a little bit. I think that'll help you to understand it. Which again, be careful on the true false one, Alex. A lot of people are kind of having a little bit of trouble just because you have to be very careful when you're reading what they give you. Make sure you actually understand the symbol. That's the hard part. And make sure you're answering it to what it's asking for. Okay? All right, so 2 important things about subsets. Okay, first thing that you need to make sure you remember is that every set is a subset of itself. Okay, so that should automatically kind of be true because think about that, of course, every item in my first set is going to be an item in the second set, and that's just basically what a subset is. Okay, now it can't be a proper subset, it's just a subset. The second thing that's important is that the empty set is a subset of every set. Okay, so remember the empty set is like this little zero with a line through it, or like this, right? It looks like that. Okay, now you can't put them together because that's another thing I've been kind of like looking at your homework at where people are messing up. I don't know particularly if it's you guys, but like people are putting these together, like they're putting the set containing the empty set. That's not the same thing. So make sure you use one or the other. Okay, and this just is telling me that it's either a subset or actually a proper subset of any set because there's no elements in the empty set. So if there's no elements there, then you can't find an element of the empty set that's not in the other set. So by definition, it just makes it true. Okay, so those two things are just two things you should make sure you remember just when you're trying to do the true or false. Okay, all right. So let's look at the actual examples because I feel like that's kind of going to be a little bit more helpful than me just talking on. Okay, so I did the first one with you, and I just want to kind of write down some important things about this because I'm trying to get you, based on what you do here, to basically answer these last two questions on the first page. Like, come up with a formula that's going to help you to determine the number of subsets no matter how many items you have. Okay, so let's look at the first one. So the first one I did with you, and I had 3 items in my set, and I got 8 subsets. Okay, so let's go and look at number 2, because number 2 I asked you to do. Okay, so maybe someone besides Michael, because she just answered, want to maybe try to tell me what do you think the subsets would be for cold and flu? So somebody else, it's okay if you get it wrong, I just want you to try it. Anybody else? You can try it, Bryson? Okay, what do you think?
Do you want us to name how many items and subsets they have, or name like the names like cold, flu, and then cold flu?
Tell me the subsets first, and then we'll like write a summary underneath of like what you found. What you think?
Okay, well, I had cold
By itself,
by
right?
itself.
Uh-huh.
I had flu by itself.
Okay.
And I had cold and flu together.
Okay.
And I had the
Empty set?
yeah.
Yeah. Awesome. All right. Very good. Perfect. Good job. Thank you. Now, also, just so you know, when you put this in Alex, you're gonna have to put it like the set containing all this. So they're gonna make you put like brackets on the end like this. Okay. So just be careful. I think they make you do that. And make sure you also put commas in between. They're very picky. Okay. Make sure you also don't put this in the brackets because it's only the empty set, not the set containing the empty set. So just, I had a few emails of people like, they're marking it wrong, but it's really right, and they almost always put this in brackets. So don't do that, okay, because that's not the same thing as just the empty set. Okay, so perfect, this is correct. Now, if you looked at the set, we had 2 items in this set, and we ended up having 4 subsets. Okay, so we're going to use that to help us in a second to answer that first question. Okay, also one other question. This is absolutely correct, but why did Bryceland not have to make another set that said flu, cold? Like, why didn't she have to put that as another subset? Anybody know? This is right, so she did it right, but why did she not have to make another set that said flu, cold?
Because it doesn't matter what order it's in.
Very good, that's exactly it. It's because it doesn't matter what order you write the items in, you just have to write them, right? So all you're doing is just grouping them together until each one goes with each thing, but in no particular order, okay? All right, so let's look at the very third one. Okay, so somebody else besides Michael and Bryceland want to tell me what the subsets of 1, 2, 3 would be? Okay, that's wrong. Okay, tell me your name one more time.
Summer.
Summer? Okay, Summer, thanks so much. Tell me what you think they are. Very good. 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 Okay, good. Okay. 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 Very good. And then the empty set. Again, Alex is going to make you like put a big bracket around these two things. So make sure you do that when you're typing it in. Very good. That's awesome. So once again, we had 3 items in our set. And we ended up with 1, 2, 3, 4, 5, 6, 7, 8 subsets. Okay, so this is not a coincidence that the number of items and the number of subsets are correlated. Okay, so like, let's go back and kind of think, if you remember on like the 1.3, how we were kind of like making like, in section 1.3, we were making like nth term formulas. Okay, that's kind of what we want to do here, and that's going to be the answer to this first little line under here where it says like, use the information to find a formula for the number of subsets. So this formula is going to be true no matter how many items we have. Like we'll be able to plug in the item number and then find out how many subsets. So that way we won't have to write them out each time if they don't ask for that. Okay? All right, so does anybody notice something about the number of subsets we have? Does anybody notice something special about the numbers? So we got 8, 4, and 8. Anybody notice something about them?
They're all multiples of 2.
They're all multiples of 2. That's how they're all even is basically what I was looking for. But you went even better is that because I was going to say then, well, what can we do with even numbers? We'll divide them by 2, right? So if you notice that they're all even. So that's not a coincidence. Okay, so they're actually always going to be, your subsets are always going to be written in 2s. Okay, so actually to figure out the number of subsets, we're just going to have 2 to the n power. And n is just going to be the number of items. Okay, so like right here, I had 3 items. So that means I need 3 2s. 2 times 2 is 4, 4 times 2 is 8. Okay, so that means that every time I have 3 items, I'll always have 8 subsets. If I had 5 items, then I'd have 2 times 2 times 2 times 2 times 2, whatever that number is. That's how many, I think 32 maybe. That's how many subsets I'd have. Okay, so in Alex, you have to be careful whether they're asking you for the number of subsets or you to actually make the subsets. So if they're asking you for the number of subsets, you can just use this formula and type in a number. But if they actually ask you for the subset, you'd have to write it out like this. Okay, so remember I told you that there's only one difference between the number of subsets and proper subsets. I said there's only one difference between their definitions. So anybody know maybe a formula now that could help us define the proper subsets? Since now that we know subsets, almost the same thing.
Do 2n minus 1.
Very good. Okay, so you could do 2n minus 1, or 2 to the n, I should say, minus 1. Okay, and why can we just put a minus 1 there? Like, what's the only difference we talked about between the two?
Proper subset doesn't have the original set.
Very good. Okay, so the only difference between proper subsets and subsets is that we still have all these subsets, but we wouldn't have this one because this would be the proper subset because it's the set that contains itself. Just like in this one, we have all these, but we wouldn't have this one. Okay, so we just subtract 1 from my total number. Okay, so these number of subsets is always going to be an even number. The number of proper subsets is always going to be an odd number because we're always going to take away 1, and the one that we're taking away is the original set. Okay, because that's the only difference between those definitions. So on the very last thing on the bottom, you could just say 2n minus 1. Okay, questions so far about subsets, proper subsets, that part? Okay. All right. So I also did, I think I did number 1 with you, but I didn't work number 2. Now, number 2, I should have probably maybe made like a little bit of a smaller set because they had so many items in it. But now maybe based on what we just did a while ago with this formula, I'm not going to make you list them out because there's so many, but does anybody know how many proper subsets we should have had based on the formula now? What do y'all think? What do you think? Oh, a little bit more, actually. What do you think, Marley? 15. Very good. Okay, Marley, how did you figure that out? Very good. Yep. So you just have to say What are y'all laughing? Did you say 16? Oh, sorry, 15. Okay, it should be 15 because you just subtract 1, right? Because it says proper subset.
Yeah.
Yeah, I keep hearing people with their masks, so hopefully y'all can hear me. I'm sorry if you can't, but try to talk as loud as possible. But yeah, so you're close. You're right. It's just because it says proper subset, you have to subtract 1. So it really should be 50 because you have Coke, Sprite, root beer, and Diet Coke, right? So that's 4 items. So you're gonna do 2 to the 4th power. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So it asks for the number of subsets. It would be 16. But if it asks for the number of proper subsets, it can't be the set that contains Coke, Sprite, root beer, and Diet Coke. So it would just subtract 1. So you would have 50. Okay, so I'm gonna put my answers on there, on Moodle, so that you can go look if you want to. But like basically, what you would do is just write like Coke, Sprite, root beer, Diet Coke individually. That would be your first 4 subsets, with just them by themselves. Then go and put like Coke and Sprite together, Coke and root beer together, Coke and Diet Coke together, and then do the same thing with Sprite, like Sprite and root beer, Sprite and Diet Coke. And then the same thing with root beer, and then keep doing that, and then you're gonna have to do the same thing, but with 3 sets, and then the empty set, and that's gonna give you the 15. So maybe, maybe that's
I forgot to do the 3 sets.
the 3 sets is what happened. Yeah, you're not missing a lot. Yeah, you're just missing like 4 of them, and don't forget the empty set too. Make sure you have that. It just can't be the set containing itself. Okay. Questions about that? Okay, so let's go look at the true false part, which I think that part could possibly maybe be a little bit confusing. So let's go kind of look at that. I did all of one with you in the video, but do we have questions about that? We need to look at a certain one on there because I know those are kind of confusing. I feel like that's some of the stuff that people have been messing up on their homework. Anybody have a question about one? We can definitely go through 2 for sure, but anybody have a question about how I got anything in 1? Okay. Okay, so let's look at 2 and we'll kind of like talk about those. Let me erase this so we can have some space. All right. So the first one says, so this is going to be all of 2 that we're going to look at. Okay, so let's look at A. Okay, so A says the set containing 8. They want to know true or false. Is this a subset of X such that X is an even natural number? Okay, so for all these, they're just asking if it's true or false. Let's first look at where it says X is an element, or X is an even natural number. Okay, so remember, what are the natural numbers again? I remember that has to go all the way back from 2.1. Do y'all remember that fancy N? What that means?
It's like the normal numbers over here.
Very good. It's like the normal numbers, the counting numbers, like 1, 2, 3, 4, 5, 6, right? Okay, so do we think, so these elements, it's saying X such that X is an even natural number, so it only wants the even numbers like that. Okay, so what we need to ask ourselves, it wants to know if 8 is a subset of that. Okay, so basically what we need to ask ourselves is, will 8 be in this list? If we can say yes, then it's good. If we can't, then it's no. Okay, so what do we think? Do we think this is true or false? True, because these sets are going to be like 2, 4, 6, 8, right? So it will have 8 in it. So this one is true. Okay, let's look at B. So the next one says 6. Is that a subset of 1, 3, 5, 7, ... Okay, so this one's asking us almost the same thing, except now they have the odd numbers. So is 6 gonna occur somewhere in this list? No. So because it's not, that means it is false. Okay, so I didn't give you this one, but just think about it for a second. Let's say I said, I don't know, just You don't have to write this down. I just want to make sure this one's not on there. Just want to make sure you've got it because I know this is what a lot of people are struggling with. So if I gave you this, do we think that this would be true or false? False. Okay, why do we think that this one's going to be false?
Because 2 isn't in that set.
Very good. Okay, so when you're looking to decide if this is a subset of this, whatever the first one is, you have to have whatever these elements are inside of here, they have to also be in there. Okay, so like since 2 is not in there, it makes it false. Okay, and so like if I would have put 1 and 3 though, then it would have been true. Okay, because then 1 and 3 would have been in there. Okay? Alright, let's look at C. Okay, so actually I did only kind of some moves on accident. Okay, so we have 2, 3. And this is saying x such that x is an element of the natural numbers. Okay, so what do we think for this one? Is 2 and 3 going to be in the natural numbers? Yeah, so that one's going to be true. Very good. Okay, so let's look at B. B is A, B, C. And we want to know, is that a subset of letters of the alphabet? Okay, so let's look at these. Okay, so remember this just means a proper subset, right? So that just means that not only we have 2 things that we have to ask ourselves. Are all of these going to come up in here? And is this going to be equal to this? That's the 2 things we need to ask ourselves. Now, I didn't mean to confuse you, but some people in the other class were a little confused because of like that math problem I think I did a while back. But when I'm saying like right here for letters of the alphabet, I literally mean like A through Z, like not just the letters that are right here. So like I want to know, is A, B, and C a proper subset of all, like if this was A, B, C, D, all the way to Z? So what do we think for this one? Because I think this is where people maybe are getting confused because they're not feeling like, I don't think they really understand what proper subset is. So what do we think? Do we think this is true or false? True. Yes, this one is definitely going to be true. Okay, why is this one going to be true?
Because A, B, and C are in the alphabet, but it's not equal to the alphabet.
The whole entire thing. Very good. So when you're looking at proper subset, that's what you need to ask yourselves. Okay, you need to say, okay, well, are all 3 of these going to be in here? Yes, they are. But are these the only letters in the alphabet? No. So it is a proper subset, so it's true. Okay. All right, let's go and look at, let's erase this so we can fit it right here in this video. Okay, so this one says the empty set is an, I'm going to ask you what this little symbol means. Okay, so let's go and look at this again. Okay, so this says the empty set, and this is a symbol we haven't looked at in a little while. That's from 2.1. Anybody remember what that symbol means? Oh, good job, Rebecca. Okay, good job, Rebecca. Okay, so it means the empty set is an element of. Do you remember what the element of means? Like what that means if it's an element of the set?
Like it's part of it?
Very good. So it just means it's part of the set, right? Okay, so that's different than a subset. So is the empty set, do we think that the empty set is an item in this set? No, very good, Marla. You're shaking your head. No, you're right. It's false. Okay, so the empty set is not part of the set. Now, if it said, like for example, F, you see where it says the empty set is a subset of red, yellow, blue? Now we have to refer to that note that we put on the front of our page on the very beginning when we talked about this. So the empty set is a subset of any set, but it is not necessarily an element. Okay, so make sure you pay attention to the difference. I think this is where I'm saying where the true and false could get tricky. You have to just pay attention to what it's asking you. So It's not necessarily an element of every set, but it is a subset of every set. So this one would be true, just by that note on the first page. Okay? Subset it is, but it's not always an element. Okay, and then the very last one, this is the one people have been getting confused with, so hopefully you will not. Okay, so let's see about this one. So we need to ask ourselves two questions when we're talking about proper subsets. We need to ask ourselves first if all of these are in here. And then we need to see if this is equal to this. Okay, so first of all, is this a subset of this set? No. Okay, it's not a subset of this set because see how this has everything except for 100? So that makes it not even a subset. So there's no way it could even be a proper subset. So this one is actually going to be false. Now, if I flipped it around though, so if I did 200, 300, 400, and I said, is it a proper subset? If I did this, now this would be true because are all of these items in here? Yes. Okay, is this equal to this? No. So that means that it's true. That's the two things you have to ask yourself. So basically anytime you're talking about like proper subset or subset, whatever is first is usually going to be shorter than whatever's second for it to be true. Like whatever's in this one has to be in that one for it to be true. That kind of makes sense. So the opposite way around, the order does matter. The opposite way around this is true because all these are in here, which makes it a subset, and then it's not a proper subset because it's not equal to this one. Okay, questions about that? Because I know that people are getting confused on that on their homework. So I don't know specifically if it's you guys. I don't remember people's names. I just went and looked at like the questions that were most wrong. So let me know if you have questions. Anybody have a question? Speak now if you have one question. Sure, you're okay. Okay. All right. Okay, so the last part of this chapter, or of this section, not really the whole chapter, is talking about union and intersection. So, of course, it's adding on some more definitions for us to talk about. Okay, so I just kind of want to show you, like, just talk about a little bit about what the definitions are before we kind of go into the answers. But remember that if you watch the video, that intersection, so this one down, means everything of what they have in common, whereas union means what they share. Okay, so the intersection is what they have in common. Union means what they share. And when you're writing this out in words, this is the and this one is the or. So just because like when we're going to bring this all together into the other sections, it might be helpful to remember that intersection is associated with and union is associated with or. Okay, because think about for intersection, it means what's in both. What do they share? What's in A and B? Whereas the union is basically what's in A, what or in B, or both of them together. Like it's everything. Okay? So that might just be helpful when we bring it towards like Venn diagram stuff, I feel like. Okay? And then if they share nothing, we just have a special name for them, which is called disjoint. Okay, that was the other definition. Okay, so I did all of one with you, but do we have any questions about one? Any of the ones in one? Okay, well, so let's look at two. Okay, so I'm kind of going to do this out of order because I want to kind of like put the answers on the board to kind of help us. Okay, and so we're going to look at first letter B. Okay, so let me see if I can get anybody besides Michael because she's been answering. So maybe tell me, what do you think A union B would maybe be? Okay, if it's wrong, okay, let me try. First one, what do you think?
Math, science, school,
School. English and history. Very good. Yes, ma'am. Awesome. Okay, so all she did, that was perfectly correct. All she did was go to A, and I like to do it in this order, but would it have been wrong if she did it in a different order? No, because remember, it doesn't matter what order you write stuff in. Okay, so all she's going to do is go to A. She wrote down math, science, and school because that was A, and then she went to B, and the only thing that she needed was English and history because she already had school. So you just don't repeat. Very good. Okay, let's look at E now. Okay, so E is B union C. Okay, so somebody else besides Michael and Bryson try maybe B union C. Doesn't matter if it's wrong. Tell me what you got. You want to try, Rebecca? Thank you, ma'am. What you got?
English, history, school, arts, and band.
English, history, school, art, and band. Very good. That's going to be correct because all she's going to do, all Rebecca's going to do is write down B, which is English, history, and school, and then C is art, band, and school, but don't repeat, so you only write school one time, and she can write it in any order. Very good. Thank you, ma'am. Okay, let's go and look at F, actually. Okay, so this is one is going to be a little bit harder because I just feel like you'd have to do like a little bit of work before you get to the final answer. Okay, so maybe somebody different. Anybody want to try what they think the answer would be for this one? Even if you like you didn't work it all the way, if you even just know what you would find first. Okay, so you just tried though, Rebecca. I appreciate it.
I'm thinking you find everything in common for A and B.
Okay, so that's where you would start. So think about like what you regularly would do for like math, right? Think about like when you solve a problem that has like normal numbers, not these crazy letters. You would go to parentheses first. Okay, same thing here. So very good. So the first thing, this is not my final answer. I could just kind of use this as like scratch work, right? So Rebecca said, let's go and find what's in common between A and B. Okay, anybody see something that's in common between A and B? School. Just school. Very good. That's the only thing in common. So I want the intersection. So I want to write only what they share. Okay, so now I want to combine that with everything in C. So definitely school. Okay, what else is in C that I would need to write? Art and band. Very good. Art and band. That would be the answer for that one. Anybody have questions about that? Okay, well, so let's go to maybe C, because that one might be a slight bit harder. So for C, we want A union B intersects C. Okay, so maybe for this one, what will we start out with first? What will we find first? A union B would have to be first, which we already found that. That's this, right? That's why I want you to do this first. Okay, so we already found that. So now we need to see what does that intersect with C. Okay, so out of all of these, only up here, what does this share with C? Anybody know? School, very good. Whoever said school, that's absolutely correct. So if you look at what we have here, we take this, compare it to C. The only thing it shares is just school. So I would put in Alex, or my final answer would be just school. Questions about that one, because they're going to start to get a little bit harder. I feel like as you start going to like the complement and stuff like that. Anybody have a question? Okay, so let's go to A next. So A is A prime intersect C prime, or A complement intersects C complement. Okay, so this time I don't have any parentheses, but I have some primes. So like for me, I feel like the easiest thing to do first would be to find my prime sets and then go and find the overall answer. Okay, did anybody try that has an answer? Just to see you try to make. What did you get as your final answer?
English and history.
Okay, let me see. Yep, that's what I did. Very good, good job. Okay, so for A prime, you would want to go to the universal set and look at set A. That's what I would find first. So the universal set and A both have school, so don't write it. They both have math, don't write it, but they don't both have English. So I'd write that. Okay. Then they both have science, but they don't have history or art or band. Okay, so then I would also go and find C prime. Okay, so I do the same thing. Look at the universal set and then put what's in the universal set but not in C. So they both have school and then they don't both have math. So you gotta put math. They don't have English, science, and history. Because C has art and band. So now I want to put what these two share, and so the only thing they share is just what Michael said, which is English and history. So very good. So this would be your final answer right here, which is just English and history. Okay, so that's where I'm saying that like maybe if you did like the scratch work and you messed up a little bit, I could go back and look and give you some credit if you didn't get it right. Okay. All right, so the very last one is B, which is A intersect B complement intersect C. Anybody get an answer for that one, maybe? Anybody else get an answer that one to say maybe what it is? No, not sure. What'd you get?
Art and band.
Yeah, that's right. That's what you should get. So, okay, so what'd you go to first?
So I did A intersection B. And
Okay.
then I got school and then I did the prime of that.
Very good. Okay, so first thing you would do is go to the parentheses. So do A intersect B. Okay, well we already did that right here, which is school. So we have school, but we want the prime of that or the complement of that. Okay, so what we're gonna want to do is take school and we're gonna write everything in the universal set except for school. Okay, so that's basically gonna be all this over here. So like A intersect B is gonna be English, math, science, history, art, and band. Okay, so that whole entire thing, basically everything in you except for school. Okay, let me make sure I didn't miss any. Yeah. Okay. Then I want to know what does that share with C? Okay, well, so if I look at C, then the only thing that shares is art and band. And so that should be my final answer for this one. It just shares art and band. Anybody have a question about any of those? I think like the main thing for that is make sure like you kind of look at the parentheses first. If there's no parentheses, then I would definitely try to focus on the prime part first. Yes, sir. Markham.
I never know when we have homework. Like,
What do you mean?
I never know when we have homework.
We always have homework. Every section.
I'm confused. Let me explain. I'm confused because I played football,
Uh-huh.
and I came from a JUCO, and like the system was like, it told you like, when you have homework, like this one, I never be knowing like.
Well, so every time we do something, there's always a homework associated with it. So like any of that pie chart that you have.
I don't even know about that. I swear I don't.
So you need to go on your Alex and click like there's some 3 little lines that say assignments, and it'll tell you like the due dates underneath it. It'll show you what. So if you have a little bit of time and you have your laptop, I will show you what it looks like. Okay. All right. Anybody have a question about this section so far? Or even if it's something on an Alex problem, like I don't mind also like if there's something in Alex that you don't know how to do and you like have it up and it's from this section, like something like this, if you call it out to me, like I don't mind working that as well if you have questions. So like if you even if you write it down or whatever is easy for you. Okay, so does anybody have a question so far? All right. Okay, so that's everything from that section. So let's go look at 2.3 now. Okay. So here's where it's going to start from like here until the end, I feel like, is where it kind of gets a little weird because it's kind of going to start making you apply all these definitions into one thing. Okay, and they're going to usually make you do it on a picture. Okay, so the very first thing that they're going to talk about, like this section is talking about Venn diagrams. So I'm going to give you, like I know they gave you one that's kind of weird, so we'll talk about that. And then we'll move on to kind of like the shading part that they give you. Okay, so the first thing that they give you that's kind of weird, just to make sure you understand it, I'm going to just give you an example. So usually for a typical Venn diagram in our class, there's usually going to be like 2 to 3 circles. Okay, now in the first part, I think the first thing they ask you to do in Alex is just like slide elements into the Venn diagram. Okay, so and then at the bottom, they have different ways to arrange the circles. So we'll talk about that too in a second. Okay, so the first one or example that they gave you, just so I can kind of show you how to work this. Okay, so this is the universal set, and this was just one that I just pulled for you, just to kind of show you what I'm talking about. Because I did have some people asking about a question like this, so I just want to make sure that you understand it. Okay, so in this case, this outside part is all going to be the universal set. It's going to represent everything, the world. Okay, and then you might have, like, you're going to have a set that's Y and Z, and it's going to be labeled for you. Okay, and then what you're going to want to do is start throwing the items in the Venn diagram, like dragging them in. That's what they ask you to do. Okay, so do you see that 6 and 8 are in both Y and Z? Okay, so typically I would do this. I put it in the middle because that's the shared part, right? Okay, and then the rest in just Y, I would put 1, 2, 3, however order you want to drag it in. Y'all see that, where I'm getting with that? Okay, so then I already used 1, 2, 3, and 6 and 8. Okay, but 4 is in none of them except for the universal set. 5 and 9, right? So you can just go put that wherever you want in the universal set. Okay, and maybe 7, huh? 7. So you go put that somewhere. Okay, now this is how you would typically set it up. However, Alex is not going to let you leave any of the circles blank. Okay, so this is the way that we're typically going to write it. Okay, but you see how Z has like no parts in it? Okay, well, so then there should be an option underneath that allows you to like put the 2 circles together. So like you see how like the only items in Z are 6 and 8, and those are also part of Y. So it's gonna ask you to select on the bottom to like make the circles go together, and then anything in Y would be like this. And then you would just put your universal set like that. Okay, it's just because they don't want it to be blank. So I think they give you like 4 options. So the first option might be like the 2 circles like this. Okay, but then if it has a spot that's blank, you're gonna have to change it to something else. Okay, hang on 1 second. So then the second option is this, where like you have the small circle and the big circle when one set has everything inside of another set. Then you have it flipped, like what if it's Z and then Y, and then I think you have it as just the 2 sets completely separated if they share nothing. So usually you're just gonna have to rearrange it if like you have a spot blank. Y'all see what I'm kind of talking about? Does that make sense? So like if one set is completely in another one, you're gonna have to choose one of these so that it's not blank. Okay? Yes, sir, Mark.
Wait. Also,
Okay, why? What's wrong?
like, never mind.
No,
Alright.
no. Tell me what you think.
I'm confused on the whole thing. That's why I said I'll ask you later.
Okay, so like they're gonna give you like some sets, and then they're gonna draw a Venn diagram on the side, and they're gonna ask you to draw the pieces in. Okay, so a typical Venn diagram, like the outer box is like the universal set.
What that mean?
Like it means like any item that like this. It means this, the universal set. These are all the items I can choose from.
Oh, alright.
Okay, and then this is gonna represent like this part represents just the items in Y.
Oh,
This part just the Z, and this part where they overlap. Does that sort of make sense? But
Yeah, I caught up on everything.
okay, and then once you like, if you have a piece missing, like see how these have no items in it because this is in the shared one, then you have to click the one where it's like the two circles inside of each other because like this is all of Z, but it's part of the other set Y.
Because it's not by itself.
Because like if this would have like a 3 in it, or like let me make it. Let's say it would have like a 9 in it.
Yeah.
Then you could just leave it like this because you could put a 9 right there.
Alright.
Does that make sense,
That makes a
y'all?
lot of sense.
Does everybody else know what I'm talking about?
Yeah, still, y'all. Sorry.
Okay, so like once we keep going with the shading, like I think they always give you that option to like move around the circles, but for the most part, you shouldn't really have to. I don't think most of them are going to be overlapping, and like unless you just have this random case where like there's something not there. Okay, so now we're gonna go get into this actual shading part, which is kind of annoying. Okay, so I did 1, 2, and 5 with you. Okay, but does anybody have questions about how I got the answers to 1, 2, or 5? Because I know this part's kind of weird. So it's basically just like what we did in the other sections, is just taking that stuff from the other sections and just kind of putting it together in a picture instead of like writing it out in a list. But it basically still uses all the same stuff. Okay, so anybody have a question about 1, 2, or 5? Okay, can we just go? We'll just go and like look at the rest, and I'll probably just have to draw it for you because I don't know how else I could really do it besides that. Okay, so let's look at 3. Okay, so 3 is A intersect B prime. Okay, so I would recommend if you have like different colored pencils or highlighters or something like that, that you probably use that when you're answering these questions. Or you might, the only other thing would be like maybe to write a bunch of different diagrams. That would maybe be also easier. So this is another place where like, if you could do some scratch work, it might help you to get the answer. Okay, and also help me to see if you mess up somewhere. Okay, so just like last time, because remember I said we're just throwing this together on a picture. So we always want to focus on if there's parentheses first. Well, this doesn't have parentheses, but it does have a prime. So that's the next thing I would probably go to. Now remember that just like before, this represents the universal set. This part is just A, just B, and this part is what they share. So like keep that in mind. Okay? All right. So first thing I would probably do is find this part, the B prime. So I would I want to shade everything except the B circle because I want just not B. Okay, so usually when you're going to have that prime, you're going to need to have that universal set. Okay, so not B is going to be, of course, this A circle and the universal set. Okay, so this is not my answer. This is just the not B part. Okay, so that's probably what I would have did first. Okay, then for my answer, and I'm just gonna write two different diagrams because I don't obviously have different colors really, or maybe I can have a little bit of a blue, but I'll still do this because I think it'll be easier to tell. Okay, so now I kind of want to look at these two things together. So I want anything I shaded here and what it shares with A. So of what I shaded here, my answer is going to be what this part shaded shares with the A circle. Okay, like if you need to, you might even want to shade like, okay, like this is the A circle, right? All of this. So this is A. So what I want is A intersect B prime. So my final answer is going to be this sharing with this. So do you see that the only thing they shared, like this part of the circle? So like my final answer should be just that right there. You have questions about that? Because I know it's super weird. But this is the only thing that they're going to want you to put in Alice. Is just that part. Anybody have a question? Okay, let's look at 4 then. I'll just put it right here and then I'll erase. Okay, 4 says A complement or A prime union B. Okay, so if I were doing it, the first thing I would probably do is find A prime. Okay, so A prime is going to be everything except for the A circle. So like all this universal set, all this, but not the A circle. So like all this too. Okay, so that's the first thing I would do. Then if you want, you can make another one that has the B, like just B. Okay, well, so just B is like this whole B circle, anything in the B circle. Okay, now the difference between this one and this one is this one wants only what they have in common, but this one wants everything that you shaded in both of these circles together. So my final answer for this one is going to be anything I shaded out of this. So all this, so all the universal set, and all of that. So that would be my final answer for that one. This part right here. This is what they would want you to put in Alex. Questions about how I got that? No? Yes, ma'am.
Why did you shade in the part where A and B are together?
Together, the intersection. Okay, so this time I want the union, right? So union means everything in both of the pictures just on one picture. So you see how, like, for B includes this part? Because, like, think about it like where they're overlapping, right? Like, I try to think of, like, if I wrote it out, right? Then whatever is in here is also going to be an A. Like, so, like, if this, that, like, think of the one I gave you a while ago. Like, think about the 6 and the 8, right? Like 6 and the 8 is in here, but it was also in here. So like B, anything in B is also where it overlaps with A. Like, does that sort of does that help?
Yeah, I just didn't have it shaded because it was like a part of A, so I thought it meant
that you couldn't include it, right? But this is where they both have the same item, so this is still like a part of B. Does that make sense?
Yeah.
Yes, sir, Mark.
Why you shaded like just the circle on B on one of them and then outside the circle?
Okay, that's a good question. So you see how I have this little like dash here, this little like complement? Okay, so anytime you have this little dash, you gotta pretty much use the universal. Like almost every time you're gonna use the universal set. Because remember think about so when we were writing the list on the other one. When we had the little dash, we had to use the set in the universal set. It's the same thing here, it's just a picture. So this outside represents the U, that U. So anytime you have this dash, you're gonna shade like not that. So you're going to shade not A, so nothing in A, but then everything else. So I shaded all the rest except for A. See what I'm saying? But then this one, I wanted B, like just B. So I'm going to shade the whole B circle, which is...
So why you did just B? It told you to do that?
Yeah, because look at my problem. I did this, and then I put them together.
Alright.
See what I'm saying? So like, everything that was in these goes together. Does that make sense?
Yeah. So why don't you just do that from the start? You just do it to simplify it, like to make sure.
Yeah, like why don't I just do this right away?
Yeah.
You can if you can see that. It's just like for me, I feel like it's easier if I look at the pieces and then make it into one. Because like to me, I don't just look at this and be like, oh yeah, shape. Like It's easier to look at it separate and then find the answer. But if you can do it, then yeah. It's just that if you make a mistake, I can't go back and see. But like if you do this and you make a mistake, I could like, okay, like Bryceland just said, oh well, I had it all shaded except for this one. Well then if she wrote this all out, I could be like, oh well, she just messed up right here, so I can maybe take off like a half a point instead of like, see what I'm saying? Because you pretty much knew how to do it.
Yeah.
So that's the other benefit of writing it down, is that I can go back and see what you did. Okay. Questions? Okay. All right, let's look at number 6, because that one's probably the hardest. Okay, so for number 6, we had A intersect B prime union C. Okay, so this time I have 3 circles because I have A, B, and C. And then this is always my universal set, the outer part. Okay, so for me, I would focus on this part first and then go and find the rest because I have that parentheses there. Okay, and so I don't even, like, you might also need to, I don't know how much you'll need to do, but like you want what not B shares with A. So you have to be very careful, like, when you're shading that. Like, I don't know if you would need to, like, maybe, you don't necessarily need this, but if it would help you, you could come on the side and, like, say, okay, well, what is not B? Okay, well, so not B is going to be all the universal set and just not the B circle. So, like, anything that's part of the B circle, you can't shade. So like even where it overlaps. So like this is not B. So like if you need to do that, you could, and you might even need to say, I don't know how much you need to draw. It's just gonna be whatever you need. So like if you had A, so A is like this whole circle right here. So this very first part, like A intersect not B. This first part is like basically what these two things share only. So like look at what I've shaded here and then look at what they share. So do you see that they only share, like, it looks like this little part right here and this little part, you don't see that? So like I would shade all of this and right here. So far. Because that's the only thing that they share between these two. And then I want to union, so I want to combine that with C. So now I'm going to shade anything in the C circle. So this should be my final answer for this one. Questions on that one, because that one's weird, I feel like. Again, though, I feel like if you take each piece, like even if you literally need to draw out every single part, I feel like if you have to do that, just do it. So like, if I need to do not B, remember that means just don't put anything in the B circle, because all of these are the overlapping parts, but that still includes B. Okay, so that's why I'm shading everything else. And then A, anything in the A circle, including the little pieces.
So in that B square, you shading in.
This one you talking about?
Yeah, you shading in the part that A shared with B.
So I shaded in. No, I didn't shade in this part right here, like because that's still part of B.
Yeah, you don't shade anything that's in that.
In the B circle, because this is, think of this as like not B, like.
Yeah.
So if that's part of B, so no.
So
but,
the B was the dash behind it. What that mean?
That means not in it. That means like B prime or B complement.
So what's that in is, like the upside down?
This means what they share, what they have in common. So like this is my not B, and then this is my A. So then what they share, like what do these two pictures, where are they shaded the same? Well, they're shaded the same right here, see?
Yeah.
And they're shaded the same right here. So I went and put that one here. And then this up one means everything. So I shade what I just shaded and anything in the C circle that I didn't shade. So those. Because that means everything. Does that make sense a little bit? Okay, so that's pretty much the questions on the front. Do we have any questions about those? Okay, so the back part is basically just making you do the same thing. It's just that it's like, instead, it's just going to give you two different things to shade. And then if they're in the end, the answers are the same, then they're equal. If in the end they're not the same, then you say they're not equal. Usually they're probably going to be equal, but they could have a few where they're not equal. Okay, so like I did 1 and 3 with you. But do we have questions about 1 and 3? Okay, so let's look at 2 and 4. So 2, you have A intersect B prime, and you want to know if that's the same thing as A prime union B prime. Okay, so you're just going to do two separate things, and then you're going to see if the final shadings are the same. Okay, so it's basically more shading practice. All right, so first thing I would do is I would find maybe like A intersect B. Okay, so A intersect B, A with the upside down U, B means what they share, right? Okay, so like I would really shade this part right here, right? But remember, I want not that. So now my answer for this one is going to be me shading everything except for that little piece that I just showed you. So that would be the answer because I want not that. So it would be this as the answer, but I want not that. So shade everything else except for that. And so that would be the answer. So like this part right here is the only part not shaded.
So that one shaded everything.
Except for that because it has.
Yeah, one. And then the next one's gonna shade everything but A and B.
Yeah. So like watch. So I might have to do this one in a few parts. So like I might do. So like this is A, this is B, and then so this one's gonna be like my not A and my not B. Okay, so like when it says not A, I'm gonna shade all the stuff except for anything in the A circle. So like everything except for that, like that. I'm gonna shade that. And then on the not B, I'm gonna shade all of that except for the B circle. Okay, but it wants the union of these two. So I want you to put both of these two together. So the final answer for this one is going to be all the universal set. And then it's going to want these two parts. Because it wants all of this, like if you shaded all this together on one.
So each letter is like one box by itself.
Each letter you can look at as each piece. And then the union just means them together. So you see how this doesn't have this one and this one doesn't have this one? So that means these are equal and you would say yes. Like it's gonna ask you like shade the first one, shade the second one, and then it's gonna say, are these equal? Yes or no. In this case you would click yes. Because both of them for the final answers don't have the middle shaded.
I got a question, like a different way to tell that they're equal is could you do something with that dash? See how it's already in parentheses on the other one?
This one?
Yeah. And try to make it like
look like that one?
Yeah.
Yes, technically you could. Like there's some properties for it, but I just figured you already have to.
Yeah.
Instead of trying to memorize more properties, because like look how many symbols I already gave you. So like instead of making you do more properties, I figured it'd be easier to just like put it on the picture instead. Okay. All right. So let's look at. Okay, let's look at number 4, and then we'll probably maybe have to stop after that. So for number 4, we have B union A intersect C, and then we want to see if that's the same thing as A union B intersect C. Okay? Alright, so this one, again, I'm going to have my 3 circles. So A, B, C. Okay, you see how these don't have like the little prime dashes, like the little complement? So you're probably not going to use your universal set. Okay, so just kind of keep that in mind. So first thing I probably do is A intersects C. Okay, so anywhere that A and C overlap, I'm going to shade. So right here and right here is where A and C connect. Okay, then I want union with B. So then I'll just go and shade anything in the B circle, and that will be my answer. So that should be what I get for that one. That one's not too bad.
You gotta put that union in the box.
No, like it's already gonna be drawn for you on the stuff. You just have to shade it in. Yep. The box is already gonna be there. Okay, and then you'll have A, B, C. Okay, so first I want to do this, then I probably want to do this, then put it together. So I want anything in A and B. So any part of the A circle, I would shade, and any part of the B circle, I would shade. Okay, so that's this first part, which is A union B. Okay, I probably want to make another one that has A, B, C. Okay, so then I want B union C. So now I'm going to shade anything in the B and C circle. Okay, and the very last thing is their intersection. So their intersection is going to be what the 2 circles share. So out of this shading and this shading, what do they share? Okay, well, they definitely both have these little pieces right here, so shade that. And then this. See, they both have here and here, here and here. So does that look just like this one? Yes, so we would say they're equal. Okay. Questions about that one? So the very last part we might be able to do really fast. I don't know if we'll be able to do the whole thing, but for the very last part is just asking me for the cardinality, which is going to lead me into when I get to 2.4, which 2.4 is really just like kind of putting this together, like understanding the Venn diagram / putting it together with a word problem / analyzing it. So it's kind of all of it. So I did number 1 with you, which was just you kind of like throwing the stuff in the Venn diagram. But for number 2, did we try number 2 maybe? Did we get some answers for that one? So I think for 2, A and B, that should be kind of easy, maybe, hopefully. That's just talking about however many items are in that. You really don't probably need the Venn diagram for that one, but did anybody get an answer for 2A? No, I'm very good, because you just count up the elements in A. What about 2B? 8, you just count up the elements. But then the next 2 parts is kind of where it gets a little tricky. So for 2C, you can't like count them twice. So like when you're going to put this on here, let me show you really quickly and then we'll stop. So you had these 2 circles, you had your 2 sets, and you had A and B. So like when you look at it, you should have saw that like A, C, F were just an A, and then G, L, and M were overlapping, and then K was in here, and then N, and P, and then in this one we had Q, R, O, T, and Z. Okay, so this is kind of how your diagram should have looked. So when it's asking you for the for the intersection, you really could just look at your diagram and see that there's only 3 things in common. Okay, you just can't make them overlap. Just like for the last one, when you count these all up, you can't count the inside twice. So like you'd have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there should be 14. You can't just like count the 2 sets together, if that makes sense. Okay, so we'll come back to this last little part. So if you have any questions, you can let me know. If you don't have any other questions, then that's all I have for you today. We'll finish that last part in the last section when we come back on Tuesday before our test. Okay? Y'all have a great day. And Mark, if you want to come see right here, I can show you what my Alex kind of looks like.